What's going on, guys? We have this question right here. The pillars are used to grip the tube at B. If a force of 20 pounds is applied to the handles, determine the internal shear force and moment at point C. Assume the jaws of pillars exert only normal force on the tube. So let's see how we can do this. First of all, I'd like to, so we are going to calculate this, but we need to find some force here, so then only we can move to this one. So in order to do that, I can take movement around A. So if I do, before I do that, I draw a diagram of this one. So it's going to be like something like this, right? Okay, so we have something like this. So I'm drawing the diagram of B. So it has a thing right here. So what's going to happen is when we pull this one down, this is going to push this one up, right? So it's going to be this going to create movement with this one, so it's going to pull, the force is going to act something like that. So in this case we can assume the moment. So let's calculate the moment around A. So this is the unknown part, so we have known forces right here, and we can calculate something from here. So let's see, if I take moment around A, and let's take, so if I take counterclockwise positive, it's going to be 20. So I'm taking only one, right? 20 times 10. Why it's not 2? Because they are two different assemblies, so we only have to take one of them and solve the question. So it's going to be 20 times 10, because 10-inch distance from A. Then we have this force. Let's say this is RB. So if this is RB times this, pushing this up, so it's going to be negative. RB times the distance is 1.5 inch. So I multiply by 1.5 inch and equal to 0. If I calculate this one, I will get 133 pounds. So now we have got information here. It's 133 pounds. Now we can, so our purpose is to find the internal shear force and moment at point C. So here we have to find. So to do that, we can cut this part off and use method of section. So in this case, I draw this one separately. It's going to be something like this. And we know RB is acting on this. So we have found RB 133 already. So it's going to be RB is equal to 133 pounds. And what else acting on this? So in this case, we have to have C. So when we separate, so it's going to have normal force. Also it's going to have a shear force. So let's take this direction, and we had to find the moment too. So moment, let's say this is the moment direction. It's all assumption. You can pick any direction, and finally if the answer comes out to be positive, then you know your assumption is right and you don't have to do anything. So let's see. So if I take summation of f of y, let's since this is not a straight line, I like to take x and y along with this one. So it's going to be something like this. This is x, this is y. So if I take summation of f of y, it's going to be vc negative and rb positive, 133 pounds, and those are the two forces in the vertical. So it's going to be 0. Therefore vc is going to be equal to 133 pounds. So it means our direction is right. Then we can do summation of f of x equal to 0, and if I take this direction and solve for this one, we have nc in the x direction. That's the only force, so it's going to be nc is equal to be 0 because we don't have anything else. Now we have to calculate the moment, so let's take moment around c. That's what we want. And if I take clockwise positive and solve for this one, this is going to be positive mc, and rb is the only moment that's going to be creating, but this is acting counterclockwise and it's 1 inch from the sea, so this distance is 1 inch. 1 inch, so it's going to be minus, since we are taking clockwise positive, this is going to be acting counterclockwise, so it's going to be minus rb times 1 equal to 0. We know rb already, it's 133, therefore mc is going to be equal to 133 pounds inch and acting clockwise. So this is the final answer. We have found moment and shear force. That's all we need to find. And I hope you guys like this video. See you next time.